Hello, folks. Welcome back. This is Kieno with Kieno Training Systems, and I'm kind of excited. It's almost Turkey Day. Today we are going to do a video on discussing hydraulic systems. Okay, I was going to say if I could get the slide to come up. Hydraulic systems. These are two forms of hydraulic systems. This is what you might see in a auto shop when you get your car repaired, and this is what you would see at a ship dock. This thing moves big giant shipping containers. So how do we accomplish that? One form is by using a hydraulic system, and here's a description of one. This would be more like related to the auto shop type situation or scenario, we would call it, but hold on 1 second here. Okay. An incompressible liquid can be used to transmit an increase in pressure. Similarly, a force, or a small force, acting on a small surface and through a large distance can produce a large force that acts on a larger surface and through a smaller distance. Now, what does that mean? What I have here in this graphic is I have a small surface, and this is what it would look like if we were looking from the top down, and then we have a larger surface here. And this is how the surface would look from the top down. So this is a closed system, and we have an incompressible liquid. What does that mean? It cannot be compressed. Alright. So it's going to resist pressure, or if we apply pressure here, it's going to build pressure here. So basically, what we're doing with a hydraulic system is just we have a closed system. We have a small piston, a larger piston on this end, and if we apply movement here, we can exert greater movement in this area. Alright? And pause and just look at it again if you are having an issue understanding that. Now, to our question. A hydraulic system is comprised of two square water columns. One column has a surface of 3 by 3 meters. So we have 9 square meters on that side, and the surface area of the larger surface has 12 meters by 12 meters, so that is 144 square meters on this side. How far do you need to compress the piston in the smaller column to raise the larger column 2 meters? So what the question is asking, how far do we need to push this in order to make this piston raise 2 meters? Alright, so first we need to familiarize with a formula: volume, area, and height. Volume, which is going to be in cubic meters in this case. The volume is never going to change. Okay, we need to understand that this is a closed system. The volume is never going to change. It's going to be the same. The only variables that we are going to have is the area of the pistons and the distance that they move, h. Alright, so this is kind of cool. Just to get that in your head, the system, the volume's never going to change. The only thing is surface area and distances. They're the only things that are going to vary. Just looking at my talking points to make sure I get everything out. Alright, so we're looking at the larger piston, and like I said, the volume's never going to change. Alright, so 12 times 12 is 144 square meters times 2 inches. So what we're looking at is, okay, well, the question is asking us, how far is this guy going to have to be pressed in order to move this guy 2 meters? And so we have to look at the volume and the distance, and we have to see what's going on this side. So we have 144 square meters and 2 inches, and we will multiply that, all right, and we will get 288 cubic meters. Alright, so now this number's never going to change. And we just apply it to this. Now we know that we have 9 square meters on this end, and so we just divide, which we will do. So we look at this, now that we have calculated the volume needed to move the larger piston, we must match the amount of volume to the smaller piston, and this is going to tell us how far it needs to be moved. So we take 288 square or cubic meters. We put 288 here. We know we have 3 times 3, which is 9 square meters, and then x is our unknown. We take the 9, we take the 288 cubic meters, we divide by 9, and we will come up with a number. Alright. And essentially that's what we're doing here. We divide 9 by both sides. These 2 9s cancel out, which leaves us with 288 divided by 9, and we get 32 meters. Okay, so the smaller piston must be moved 32 meters in order to move the larger piston 2 meters. Alright, so D is our answer. And I'd just like to thank you guys. Please like, hit the subscribe button below, and please share on your social media networks. I thank you guys for watching. This is Kieno Thomas with Kieno Training Systems. Have a great Turkey Day. I will probably have another video out before then, but as we approach Turkey Day, I will. And if you don't celebrate it, happy Turkey Day anyway. Enjoy your day off if you don't celebrate Thanksgiving. But thanks for watching. Talk to you later. Bye.